guinea pig, but if it works well, always welcome back to TFGM offices. So I was asked really just, Dave Woods got in touch and said, would you mind giving us a presentation about Metrolink, maybe what's going on? He kind of said, oh, it looks like it's going really, really well in Metrolink, and I suppose from the outside view it is, but when you're inside as an engineer, you know all the problems you've got. So I regaled a few problems to him on the phone and thought it'd be interesting to hear about it, but generally it is really, really successful, and there's a few people dialed in as well from other parts of Metrolink. So firstly, I'm Pete Sommers. I'm a TFGM Metrolink engineering manager. I've been here about 4.5 years now, approaching 5 years. Previous to that, I was in network rail, and my background's electrical engineering, so I'm very much flagging it a bit today with some of the track stuff I'm going to talk about. But this is the bigger track problems that are finding their way onto my radar because they're costing a lot of money and really tricky problems. And there's a couple of colleagues I can see have dialed in who are really getting into the detail of these problems. And so if you ask me any tricky questions, I might put those colleagues on the spot. I'll give us a brief history of Metrolink, how we operate, and then how we're organised as well. That kind of differences to network rail and heavy rail that we're also used to. And then some of these key challenges and some of the other interesting things. So that is my own drawing, because I realise as a public presentation I can't just like rob things off the internet and put it on the presentation, can I? So I've done my own drawing there, but that was phase 1 Metrolink back in 1992 when it opened. Altrincham to Bury, as I'm sure a lot of us know, that was ex-heavy rail. Trains were running on it up to the point that GMPT at the time took it over. The headline stats there: 31 kilometres of route, 26 trams and 28 stops. And that is the original fleet that we had at the time, the T68 tram. Still with the block signalling apart from the city centre. Then, not quite historically correct because the Media City spur is shown, but just for the ease of my drawings, the Eccles line came next as phase 2, and that opened in 2000, and that was 6.5 kilometres of route, and 6 more trams were added to the fleet and 10 stops. And then what we call the Big Bang happened from about 2010 to 2020, and as you can see, there's a lot more squiggles on the page there. We've got a lot of Metrolink. I think for a lot of people now, especially the younger generation, it just might feel like that's what's always been in Manchester, but it is relatively new, 2010 to 2020. So the original phase 1, 31 kilometres of route, inherited heavy rail. But this phase 3, the Big Bang, was a further 61.5 kilometres of route that added to the network. The airport line, we've got, I think I've got later. Airport line down the bottom. The East Didsbury line was protected beach and cut route, I believe. The Ashton line, are predominantly on street extension, and then the Oldham Rochdale line, which that was similar to Altrincham Bury, where it's handed over from British Rail or Netrail at the time to ourselves. And the final opening happened in March 2020, just before lockdown, to the Trafford Centre. And that's where we've been since 2020. We've moved very much as a massive focus as an organisation, and Metrolink as a whole, of expanding, tripling the size of the network. We're now in that realms of looking after a big asset. It's not as new as it once was. And from a fleet point of view, I'm sure the INEC even more interested, but now got 147 M5000 trams, Bombardier vehicles, but we've been taking over Helston, and the T68s have been retired. So I wanted to bring this photo in here because it really, to me, shows, going back to the previous slide, and this slide, it really shows that different operating areas on the Altrincham line. That's my tram stop that I get on in the morning at Brooklands. It very much looks like it could be a heavy rail route, that, yet we are a tramway. And what is a tramway? The principle of operation is that line of sight operation. The way I simply understand it in my mind is that on the heavy rail, when a driver gets a proceed aspect, they know that the route is clear to the next signal. They can drive at the line speed. The route is clear. Whereas in light rail, with a line of sight system, you get a proceed aspect, but that just means you can proceed past that signal. It doesn't mean that there are no obstacles on the route to the next signal. There could be another tram before the next signal. So you drive a line of sight so you drive as if there could be an obstacle in front of you. And obviously we have the braking performance that allows us to do that. And we set the permissible speed so that you can do that. Turn up and go operation, there is a timetable. Metrolink run to a timetable, but the frequency means that we push more time turn up and go. And yeah, various environments from the city centre on-street environments to what are old heavy rail environments. Yeah, 99 stops now, 100 kilometres of route and 147 trams. So we're about 5 times bigger than the next tramway in the UK, but we're about 5 times smaller than London Underground. So it kind of gives you a scale of what we are. Pretty big, but not so big enough to sometimes to be able to do the fancy whole life cost modelling I keep getting pushed to do. Yeah, we don't necessarily get enough data. So being a tramway, we're organised very differently compared to heavy rail. We're very lucky that it allows us to have track and train integrated into one organisation, and TFGM are very lucky to have a great partner here with Keolis Amy. So we contract out the operations of Metrolink. So TFGM, we're the owner, the asset owner on behalf of the Greater Manchester people. We're a local government body, and then at the moment we've decided we contract that out, the operations and maintenance. So CAM, as we refer to Keolis Amy Metrolink, they're the operator and maintainer. They're into a 7 years of a 10-year contract and a successful partnership with us. Really, a lot of the knowledge of the network sits within the operator and maintainer, as it does in heavy rail as well. We have the ORR, but unlike heavy rail, the ORR is only responsible for safety regulation of tramways. They're not responsible for the economic regulation like they are in heavy rail. The REIB, as you'll see, they do investigations on light rail just like heavy rail. One just released lately in Nottingham. Then 2 industry bodies. The UK Tram is kind of like the industry trade body, brings the industry together. But the operators group, the light rail engineers group that sit under there, that we can all talk and share problems. And then finally, LRSSB. So LRSSB, the Light Rail Safety and Standards Board. And a bit like RSSB, but not quite as mature. LRSSB only came into being after derailment in Croydon, in Sandylands. Really tragic accident, killed 7 people, and was a watershed moment for the industry, really. And this body was created, and the industry's had to change quite a bit. And then I put all the councils here that Metrolink run through. We own the rails and the overhead line, the infrastructure through there, but we don't really own the highway that we run on in these local authorities. So we have a very close working relationship with all the local authorities, but close but challenging. We all know local authorities with a lot of cost pressure, and we run through 7 of the 10 local authorities in GM. So I think that's the headlines of how we're organised. So these are our key challenges. We have picked challenges outside of my core discipline, so these are the ones that are probably costing us the most money and the most challenging. So rail brakes. I'm sure a lot of people have seen the Great Network Rail graph that shows like rail brakes going from like 600 a year down to 50 a year. Sadly, we're kind of at the opposite end of the spectrum here, seeing an increasing trend. So firstly, thanks to Chris Fielding, who's the track maintenance engineer in CAM. allow me to use these photos. But yeah, this is the number of rail breaks we're seeing each year, and that I've done it as a kind of financial year, like 21-22, partly because most of our rail breaks come over the winter period. And you can see at the end of last winter, we'd seen a 3-year trend of rail breaks doubling year on year, so we were getting very worried about this year. Thankfully, it's not followed the same trend. We are only at about 8 on the graph, but 1 was reported last night, so we're at 9 this year. So we've not hit the same trend, but still a big problem for us. It's not the same safety risk that we see in heavy rail with rail brakes. So in heavy rail, on a big old rail, wasted track, a rail brake, much higher risk. For us, we've got that containment of the highway around the rail. That means you've got still quite a lot of lateral strains. But it is still a safety risk because here is a nice cross section of one of these rail brakes. 99% of our rail brakes are happening across the world. This S-shaped rail brake here, and our big risk that we have seen is a secondary crack starting to come up this way. And yeah, good question. What was the reason for the spike in 22-23? We're not 100% sure. We suspect it could have been the extremely hot weather that we got in the summer of 22, with I think it was peaking 38, 39 degrees C that summer. Embedded track isn't stressed, but it's still under a lot of pressure through the varying temperature changes. So it could have been that, but we think ultimately we've got a problem with the welds. And yet, if we get a secondary crack come up, we're then going to lose a chunk of the head, and our derailment risk increases much more. So there's a safety risk, and then there's the cost and what it's doing to our customers. You can go out and replace a rail brake on ballasted track overnight. Easy. Well, says the man who's never done it himself, but it can be done overnight. Whereas with an embedded track, you've got a lot of material anyway, you've got a lot of work to do. So every brake we get, it's typically, Chris's team do a great job of doing a temporary repair overnight, where a short piece of rail is welded in, but that's only temporary because we've got 2 welds within a metre of each other, so a non-compliant distance for welds. It temporarily gets us sorted, and then later on, a full repair will be planned. But that full repair requires a full shutdown of the railway for about 27 hours, a typical 27-hour possession. So yeah, we're going to lose the railway for a Sunday typically, big impact on the passenger. And the costs, it's bus replacement costs, astronomical, along with the cost of welders and teams from Canada. So we do think we've got a problem with the welds. 99% of our rail brakes are welds. We've got circa in excess of 5,000 of these welds across the network in embedded sections. So what are we trying to do? We have, with what we've got in the network, there's not much we can do. It's there, it's embedded. Chris and his team are working very closely with the supply chain to look at if we can do ultrasonic testing to find these cracks before they become a rail brake. But as it's grooved rail, so I put the cross section here, the head and the rail is offset from the web. It's hard to do ultrasonics. It's not a quick job. Trials have been done on the network, and the rate of production of testing each rail weld is quite slow. And there's part of me that thinks, why do we want to make this there? Well, there's nothing we can do about it, let's just wait. But I think on the flip side, I've been persuaded that it's at least better to know your quantum of risk, and you can potentially proactively break these out where the crack across the world gets too big. you can monitor. But until we understand the cost of monitoring the defects, we can't really make that decision. Because if let's say we can only do 10, 20 inspections a night, and you've got 5,000 across the network, you want to inspect them regularly. So the main area that we've pushed to improve, and this has worked really well, coordinating across the industry through the Lightweight Engineers Group, is let's make sure what we're putting back in the ground is decent. We know we've had a problem maybe with quality previously, let's try and focus on what we're doing next. So thankfully, our well supplier, has really come along and helped us with this. They've updated their weld kit. They had been updated for a lot of different rail profiles, but until they realised the problem we were having, and until they realised the quantity of welds we'll be doing in the future, they didn't see it as a priority for them to update their kit for our specific rail profile. So that's been done. They managed to achieve that in about 2 months. They tested it in front of us, been really impressed with them. And then from the same supplier, because we suspect that the defects in the welds are inherent from the point they are cast, and that could be to do with the preheating or the cooling. But the supplier has now produced an automated preheater, which you can see in this picture here. It looks like some weird elephant kids toy thing, doesn't it? Hoover thing, I can't remember the character, but so a really big advantage for us, because getting the preheat right is particularly hard on a grooved rail. Very specialist activity. There's not many of these welders out there. So we just tried that on the first rail brake problem fix we had using this preheater. So fingers crossed this will help reduce the amount of defective welds that we have going in the future. But we've still got like 5,000 welds in there. Many of them don't seem to be lasting the life of the rail. A big risk for us, really. So yeah, I've not really got the answer, but a lot of good work going on to make sure what we do in the future is better, and also trying to understand the quantum of the problem now. So that's rail brake. So the next issue we've got, I've just got one slide on this. Is there any correlation with rail brakes and grades? I don't think there is, Rob. I don't think there is, because I think predominantly it's all across the same grade of rail, all originally installed as part of phase 3. Apologies for missing your question, but I'm just seeing them flying up on my screen sometimes. So a really big problem we're having at the moment now, another big problem, is railhead defects. This is now in the ballasted track world. Extensive railhead defects. That picture there is from track up near Hagside on the ferry line. And I suppose it looks just like a lot of squats repeated after each other. So typically a squat defect, you can either repair it, weld repair on top, or cut the rail out and put another short bit of rail in. But frustratingly with this is the amount of defects also close together means that we can't find a clean bit of rail to weld into. And we're talking, I think in this area here, at Hagside, there was in the thousands of individual defects within a few thousand metres of rail. The problem with this, obviously with a squat defect, is it can eventually propagate down into a transverse crack and you get a full rail break. And then the other challenge is, as the defect gets to a certain size, your ultrasonic testing, or your rail becomes untestable by ultrasonics. So you don't know if you've got any other problems in the rail. So again, just to be reassured from a safety point of view, when we find this, we've got speed restrictions on. The monitoring of the rail is increased. Our inspection regime anyway is once a week the rail is walked. So the safety risk is managed, but it does also create a noise problem for residents that also track as well. So the real issue we think here is that these aren't actually squats. but they're studs. So, and our real issue with that is we don't know the cause, and we don't know the solution. We do know our solution. It's just replacing the rail. So we replace 4,000 metres of rail at the backside. The other screenshot here is just of the Ultraman line, showing where we have these defects, just on the Ultraman line, but it is network-wide. You can see circa 3,400 of these defects between Sale and Brooklands. That's why we have a speed restriction on there at the moment. We are planning to replace that rail in sometime this summer. And yes, we have looked at milling them, but a quick fag packet calculation, basically, the cost of milling, we got some quotes, Cam got some quotes for that, and it's pretty much just the same value for me to replace the rail, because the amount you have to take off, I think, is it close to 9 mil would have to take off? Yeah. So it does appear that other networks are having this issue. We do try and read up about it. We suspect there's another larger network than us in the UK that might have this issue. They found that they weren't getting it in tunnels, they were only getting it outside of tunnels. I recently read about a Canadian network that was having these issues. They implemented a different grinding regime. They think it made it worse. We really don't know what the problem is at the moment. We're just kind of managing on a rail replacement point of view. But I put studs. So there's a thought that it isn't actually a squat and it won't propagate down to a rail break. It's just a stud. And I'm trying to think.
What difference in the rolling stock?
And that's, yeah, is it a different rolling stock or a traction package? That's what people often suspect, that either you're getting micro slips and it's creating this stud-like defect that doesn't have the same properties as a squat and it won't propagate down into a crack. But you still got the noise problem, and how do you identify as a stud as opposed to a squat? Because if it's a squat, you've got a risk of a transverse break. If it's a stud, it's just noise. But your rail is still untestable. So in one sense, we paid British Steel, to do some testing and to understand this in more detail, but it's a real big expensive challenge for us. One of those ones that maybe in a couple of years I'll come back and present and say how we've solved it. Not how the teams have solved it, but it's a real problem.
Could it be based on electrics? Because you use the rails for constant traction return, don't you?
Yeah.
Could it be as the wheel is leaving contact with the rail, it's a micro spark?
I think we've considered that, but yeah, potentially corrugation induced. We think it's a micro slip on the wheel, but proving that's really hard because it is only potentially a very small slip, and that means your wheel slide slip protection on the tram hasn't kicked in yet because it's such a small slip. It's likely that it could even not be in every vehicle that's doing it. So you introduce some monitoring or you do some specialist investigation with, let's say, high-speed cameras. You bring a tram out every time, but it could be another vehicle that's causing the problem, or it could be part of the fleet. So a real challenge is for us to investigate there. So everyone on this call, if you've got any ideas, please do email me, and if you've seen this before.
When is that a corrugation and not a stud or a squat? When is that a corrugation and not a stud or a squat?
I think, yeah, corrugation looks a lot different. And we can generally grind corrugation out if we get to it soon enough. But I'm not sure quite the definition. As I say, can't. The final slide I just thought I'd show you, the challenge we have with track renewals. This is what we're kind of solving this challenge. We get on with it and do it, but the challenge is it's bloody expensive and disruptive. And if you live on the Eccles line, you'll have faced some of that disruption over the past few years. So embedded track yeah, it's great for a tramway. The beauty of tramways is it brings a railway into the urban environment, brings people right into the city centre. I think we all know how successful Metrolink is. I think, as I always say, if the BBC haven't got a picture of the victim or the perpetrator, they use a picture of Metrolink in St Peter's Square, don't they? It's kind of based in Manchester.
You're not unique in that every local newspaper's got the Metro there as a backup for the shop story.
But that is, it becomes the face of the city, doesn't it? So we are, it is well loved. But when you replace embedded track, it is hard work. This is the design on the Eccles line of the replacement. You can see we saw cut out the sides, position the rail in with a base plate, and then grout it up basically. In this instance, so you're cutting in towards the original design. The slab is now being cut; it wasn't cut before. And so we do a design for this renewal. We don't just. It's not a simple design as such, replace rail here to here and weld in, because it is modifying that slab. And sadly for us, the calculations showed that the nosing force was such that we had to reinforce the concrete shoulder with a dowel. So now every few hundred mil we install these dowels when we do a rail replacement. So this just shows the saw cutting down here on the Eccles line, and then the nice channels. A great job being done there. We've got two nice neat channels. The rails will be lifted into their position nicely, and then grouted up around. As easy as that, and says the man again who's never done it. But our first major challenge, one challenge we had, was that as the saw cut went down here, the concrete shoulder started to all break away. So that possession, we were delayed a few days with that. We lost my screen. Hopefully you can still hear me.
It's still online.
Is it?
Yeah.
Oh, cool. So yeah, this possession we lost a few days because a large extent of the concrete shoulder had broken up as we saw cut through. So we get to next year's renewal, and as you would expect, we decided we should allow for a lot of this concrete shoulder to break up and let's renew it. So we had that in the programme, we renewed a lot of it. Guess what? The concrete shoulder was fine. So then year 3 of the Eccles line renewals, we a more balanced approach. Had some risk in the programme for sure. So yeah, really tough. The Eccles line has been closed typically for 2 to 3 months or 3 years in a row to do these track renewals. And then just to show you in a bit more detail here, this is the kind of quantum of embedded track renewals we've got to do over the next few decades. A real spike coming up, which really does fit in with the fact that a big part of the Phase 3 network was a big part of the network. The Phase 3 network was all built within the decade 2010 to 2020, so a lot of it for renewal will come up now. It appears that obviously it very much depends on how much you operate over it, but some tight radius curves can need renewing every 6-7 years in the city centre, whereas plain line embedded might last more like 20 years. We're driven generally on the curves by side wear, and on the plain line it's head wear. Side wear is particularly a problem, obviously gives you wider gauge, but when you're embedded, the wider gauge means you get back a flange contact with the keeper in the groove rail, and that keeper then becomes a critical component that is wearing away. And if that wears away, your derailment risk is very high. So yeah, there are big headline track challenges. The 3 that I picked out, 3 that I felt confident to speak about that we face at the moment. I thought I'd just flag up some other interesting things in Metrolink. Climate resilience, I think kind of really important for all of us as railway engineers, but this just shows how we at Metrolink, how it affects us really, that variation in temperature. The trams cope a lot better in winter than they do in summer. Generally that is the air conditioning faults in the cabs. The cabs have air conditioning, the saloons don't. And yeah, you're in a little sun house there for the drivers. If the air conditioning is not working, it's unbearable. So we've had with CAM's rolling stock teams done a lot of work to improve HVAC reliability, but you're still pushing it really beyond its design limits now with the temperatures we're seeing. And then infrastructure. We've had some quick win improvements with our signalling cabinets. They were overheating, so we've done some modifications to them that now allows the equipment to operate to a higher temperature. So it's not that we're keeping the cabinets cooler, we've now meant that the kit can work at a higher temperature. But just being honest, I don't think we've really got our head around the scale of the problem that we face. We're very much in this area a follower, so we'll wait for Network Rail to change its stress-free temperature track, and we just have to monitor. So we're falling in now into a 5-year funding period as well, similar to Network Rail. We previously weren't, but due to the pandemic, our fundings all changed. So our next funding period is 27 to 2042, and at the moment our main tact is just to ensure that the investments we are doing have the correct standards, and we are pushing the limits on that really. So we're looking to renew the Bury overhead line very soon. So again, it's making sure that what we do there is fit for purpose to ensure we don't get balance waste bottoming out. And then finally, just some of the interesting projects or some of the interesting things going on. We've gone to 147 trams. We have 120, so we've expanded both depots to accommodate that fleet. But we need 3 new substations on the Bury line to allow us to run an all-double service there permanently. We do it on event days, but to do it permanently, we need 3 new substations, so they're being built at the moment. That mess of a construction site is Whitefield Tunnel. A few years ago, a crack was found in a wrought iron beam, so very quickly excavated above it, removed the pressure, removed the weight from it. But we're looking to renew all of those beams now. However, unluckily for us, we've got gas, water, electric, and BT all over that tunnel. So it's been an absolute nightmare. Okay, now, and I think all those services were diverted there when the road next to us was expanded. So yeah, we're facing that problem now. That should hopefully be done this year finally. I mentioned about the LRSSB and the Sandylands incident. So we have a program, TSIP, we call it Tram Safety Improvement Program, and that's to fit a system to all the trams to prevent them from overspeeding across the network, and then a driver vigilance device as well. So your typical, at the moment we have a dead man's handle, we'll have a vigilance device going forward. So that project is due to install on its first trams in, I think, late summer on a trial basis, and then we'll roll out. And we've got a very ambitious program to install across all 147 trams by May next year. And that's going to be using wheel turn GPS and sun beacons to know the tram's position to be able to intervene for exceeding their permissible speed. So really great system to really ensure that we don't have a repeat of the Sandylands incident in Manchester. We're renewing our telecoms network at the moment. A challenge, telecoms engineers will know how tricky it will be to go from your existing network to your new one. We hope to start migration of the network this summer. And then TMS, our tram management system, our signalling system, our servers all, you can see the left-hand side is our existing servers. We're doing some clever computer stuff to virtualize these servers, I'm told, which means they don't sit on their own server, they just sit as software on one other server. So 16 servers will sit in 4 virtualized servers that make us much more reliable. And then further down the line, just kind of some headlines. We need to renew the overall signalling system, facing a lot of obsolescence issues. We've got tram train, pilot schemes, hopefully starting in the next few years. New stops, one just north of Victoria because of all the housing developments going on there, and one on the Bury line and one on the Oldham line, and then line extensions. I showed you, I think, 7 councils that we were in. Everybody wants Metrolink, so our strategy department in TFG are working on that. So that is everything from me. A few of our challenges and
Excellent, cheers. Pete, that's really good. We've had some questions and skillfully you've answered some of them as you presented. I also noticed that Tom has put someone's put some photos in there showing some breaks in the chat. So I think you've answered that one. A lot of comments about the milling, squat defects. So if you, any questions in the room? First.
any answers? I will say any answers.
So we've had a question there from Dave Woods. So which routes are planned for further expansion? I'd say.
Yeah, nearly everywhere is planned for further expansion, and our biggest challenge in TFGM is to whittle those down into what we're actually taking forward. So with the mayoral election coming up, I better not say more. And yeah, Metrolink is a light rail system, a tramway light rail. I think we have done maybe a tonnage calculation, what the equivalent tonnage is, but I don't know off the top of my head. Sorry?
Plus two.
With Genesis CSO's Cat C.
Cat C, under network rail standards.
Yeah.
I can't remember off the top of my head, but it's, yeah. The one question I had was, you mentioned that you were waiting for network rail to change the SFT for stress-free temperature. Croydon went beyond that.
Did they?
Yeah, so Croydon was 31 degrees.
Oh, that's interesting.
Yeah, I've got the standard, I'll send it to you. Yeah,
Nice.
but yeah, Croydon, it was always a little bit, it was a long time ago as well, they changed it around 13 years ago. Yeah, so for the ballasting section, they do 31 degrees, I think it's 31, 13. Yeah. They decided that they get different weather than the rest of the country, so they decided on a different SFT.
Does Netherrail have one SFT for the whole country?
Yeah.
So I suppose if you're localised in London.
Well, we've kind of got two now, haven't we? So new installs 32.
Yeah.
About to say that's what we were looking at, separate ones.
Is that actually converting to 102 now?
It's not.
So,
It's in,
3, 1, it's 3.
Three-
Yeah, 3, 1, 0, 1. Yeah.
Yeah, so it's 32 for new installs, jobs and stress.
Yeah,
It's 27.
Yeah.
To help with the various usages of the line, network rail, I think network rail developing different stress-free temperatures.
Yeah, I knew that was proposed. I hadn't realised it would actually come out in a new issue. That
Yeah, I think in the last year, the year before.
I thought was
It's
just
very useful. One question from me, as you'll know from Network Rail, we use CSM as our safe integration process. What sort of process do you follow when you're making
Significant change.
upgrades? Yeah.
We follow what you used to follow. The ISV, independent safety verification with an independent competent person. So we all follow ROGs.
Yes.
But ROGs puts you to CSM for heavy rail. But in ROGs it keeps you on the ISV, ICP.
It's just SV safety verification.
Essentially, so with an independent competent person. So we are doing SV for our overspeed system on the trams because it's not the original equipment manufacturer doing this upgrade, and they're tying the brake loop. And we deemed that it was a big enough change, significant change, that we should appoint an independent competent person. But I think tram train will almost certainly be CSM led and comes off that way.
Probably would be when you're working on network rail construction.
Exactly, yeah. And we might as well just have CSM go across the whole programme.
Yeah,
just
I mean,
CSM.
Under ROGs, safety verification is just having, the bones of safety verification is just having someone independent from the project look at it. Squibble on it. There's actually nothing in ROGs or any piece of legislation that stops any organisation that comes under ROGs to employ CSM. if they feel that it is a more robust process.
Certainly a way to pay consultants more money, but
It depends on how you set yourself up to execute CSM, in my opinion. You're not wrong in some respects, but
we obviously work with a hazard log
Yeah.
and close out our hazards in a very, very similar manner to how you would with CSM anyway.
Yeah. The CSM is a mandated safety verification process for any rail because of the EU.
So one final question here from Daniel Pike. Are weld failures expected to tail off as those with defects within one gate failure, whilst those that don't perform normally?
I bloody hope so, Daniel, that's all I can say. We'll keep monitoring, and that the 3-year trend doubling every year was really worrying for us. It's not been quite as bad this year, but it's still very much above the long-term average. Long-term average being 2 to 3, and then now 9 this year.
Okay, and one final question. How do you pick up defects at the moment? Do you have service cameras?
So obviously heavy rail have their PLPR, don't they, that will pick up defects. We don't have PLPR. We run the amber trolley. We'll run the alignment geometry defects. We'll do ultrasonic testing, and then we'll routine track patrols. Because we don't have PLPR, I don't think we could, just because of the nature of the railway. We don't patrol at a much greater frequency than you do on heavy rail, but our patrols are much easier to do than heavy rail because our risk profile is different, the way trams can stop. We are looking to introduce some remote condition monitoring kit to the tram that will measure the rail profile using fancy technology, lasers and whatnot, and give us those kind of squiggly lines that we can pick up defects from. But it's challenging technology to do so. We're hoping it's installed, can imagine that. We're hoping to get that running very soon.
Very good. Okay, I think we're going to wrap up online there. Just a couple of things to point out. Next presentation is back online, and that's Beauty Station track bed design presentation by Arcadis, and then the one after that in June will be track insights from Bogota Metro by WSP. It's a change to what was in the original programme. Just a bit out of practice, basically, chairing in person. It's a lot easier than so in the room, I guess, online, or however we want to do it. Just a round of thanks to Pete for presenting and hosting. So thanks very much for that, Peter. And we will see you back online in a month's time. So thanks very much.